Do you recognize this man? He died in 1977, and yet 40 years later, his identity is still unknown, and he continues to be one of North America's 10,000 unidentified John Does. He is known simply as Delafield Doe, and while many forensic investigators continue to seek his true identity, the most important forensic tool in solving his identity is the DNA sample he currently has on file. His DNA has been compared to the DNA of 9 men on the National Missing Persons List, but so far none have been a match. But how do you go from taking a DNA sample, say from a cheek swab, to being able to definitively say it's a match? The process you would use is called Gel Electrophoresis, which is separating DNA strands according to size by moving them through a prepared gel substance with an electrical current. After placing the gel into an electrophoresis box, you would then place the missing person's DNA sample into a tiny hole in the gel. This will be our control sample that we will use to measure the DNA sample from the unidentified person. Their DNA goes into an identical sized hole in the gel next to our control. DNA naturally has a negative charge, so when you turn on a power supply and have a negative charge on the end where the DNA samples have been placed and a positive charge on the other end of the box, the DNA will automatically be repelled by the negative charge and will start to move through the gel toward the positive charge. The smaller fragments of DNA will move faster through the gel than the larger fragments. The smaller fragments will end up down at the end of the box by the positive charge, while the larger DNA fragments will remain toward the top. This process has now separated the DNA strands according to size. You can now stain the gel so that the DNA strands can be viewed on a UV light. You are then able to see how the DNA fragments match up between the missing person and the unidentified person. Unfortunately, in Delafield Doe's case, none of these comparisons have ever been a match. But gel electrophoresis is useful in comparing DNA and is used by forensic laboratories as part of the DNA comparison process.